In this video, we will learn about memory usage by the Java Virtual Machine, also known as the JVM. Let's get started. Remember that understanding the memory usage of the JVM is important for monitoring the instance or container in which the JVM is running. The memory usage displayed by OS tools like PS or top doesn't accurately reflect what's happening under the hood. Let's dive right in. Note that the JVM process requires two main sections of memory. One is the heap and the other is the non-heap. Of these two sections, the heap section is significantly larger compared to the non-heap section. This video will mainly be about the heap section. Please keep in mind that the non-heap memory section exists because the memory usage of the entire JVM process may be higher than the maximum size of the heap memory from the operating system's point of view. The heap memory section is subdivided into additional sections. Let's talk about them. The first one is init. This is the amount of memory requested from the operating system by the JVM at startup. This coincides with the JVM XMS setting. The second one is used. This is the current memory usage by the application running in the JVM. Third one is committed. This is the allocated memory from the operating system by the JVM at any given time. This will be near the amount of memory that can be observed from operating system level tools, such as PS or top. And the final one is max. This is the maximum amount of memory the JVM will request from the operating system for the heap memory section. Used and/or committed memory will never go beyond the max setting regarding the heap memory section. This coincides with the JVM XMX setting. The garbage collector is responsible for managing the heap memory. The garbage collector examines the heap section and marks which objects are no longer essential. After the marking process, the garbage collector performs a cleanup of the objects that are no longer essential. Note that although the memory was freed by the garbage collector, this doesn't mean that the memory was also returned to the operating system. The used portion of the heap will now be lower, but the committed part likely remained the same, so the operating system didn't notice the memory change. Memory being released back to the operating system depends on the garbage collector used and the JVM options specified. It's important to note that allocating and freeing memory to and from the operating system is an expensive process. It's generally recommended to avoid this if possible. Let's see an example of what this looks like. Click on the administration icon near the top right, then click on SDC metrics. Please note, we have purposely filtered out all other data to show only the heap memory usage information. As we can see here, our maximum heap size is about 2 gigabytes, but only 1 gigabyte is shown as committed. Also, less than 300 megabytes is shown as used. We can verify these startup settings by looking at the sdcenv.sh file, which contains these settings. Here, the XMS setting is 1 gigabyte and the XMX setting is 2 gigabytes. Now let's run some pipelines and observe the increase of the committed memory. After some time, the committed memory will match the maximum memory, but the used portion will change as the garbage collection runs. If you check the process with the operating system tools, you can see that the process consumes a little more than 2 gigabytes, which is the maximum heap setting. Now let's stop the pipelines that we started. Next, make sure you set the memory size to a value respective of the available memory of the operating system. Here we see that we've about 4 gigabytes of memory. In this case, we'd normally set the heap size to about 3 gigabytes, but what happens if we set it to 4 gigabytes? Next, make sure you set the memory size to a value respective of the available memory of the operating system. Here we see that we've about 4 gigabytes of memory. In this case, we'd normally set the heap size to about 3 gigabytes, but what happens if we set it to 4 gigabytes? Let's restart Data Collector. Click on the Dev Data Generator stage and change the batch size from 10,000 to 1 million and start the pipeline. Data Collector will allocate more and more memory until it is eventually killed by the operating system, because too much memory has been allocated with the JVM XMX setting. As we can see, the data collector eventually crashed. Checking the logs shows that a memory error caused the crash. Please note, if your team cannot detect a memory error in the data collector logs and the logs stop abruptly, then there's a possibility that the process was terminated by the operating system. Please check the operating system logs to determine if a process like killer was invoked. Here are some best practices. Do not set the maximum heap size, otherwise known as the JVM XMX setting, to a size which you cannot afford. In other words, do not set a 10 gigabyte heap size when the server only has 2 gigabytes. If the Java application is the primary and only application on a given server, then be sure to leave enough memory for the operating system. The amount of memory required for the operating system will vary between operating systems. Expect the JVM to eventually allocate the maximum heap size and plan for it to stay at the maximum heap size when viewed with operating system tools. If monitoring the application memory, then use tools designed to query for heap usage, such as GCMD or JMap. If your team would like to do this in an automated manner, then either a custom script can be written or an external service could be used, such as application performance monitoring. In summary, we have learned how the JVM utilizes memory when viewed from the operating system and details about the heap memory section managed by the garbage collector in this video.